Hi boys, let's move on to the last exercise, exercise 7C. So let's start with some questions. There are no new concepts. Similarly, basically a revision exercise where we use the properties learnt about indices and apply them. So let's look at question number 1. So this is, I can write this as 3 to the power 2 multiplied with 5 to the power 2 minus 3 into 8 to the power 0 is 1 minus 81 can be written as 3 to the power negative 4 because it's in the denominator, so the power is negative, multiplied with negative half. So 2 and 2 gets cancelled, so I have 3 to the power 5 minus 3 to the power negative 4 into negative half. 2 and 2, 3 to the power 5 is 81 into 3, that's 243 minus 3 to the power negative 2 into negative 1, that's 2, so that's 240 minus 9 is equal to 231. Perfect, simple. Let's try question number 1, part 3. So I notice there are many powers, so let's try and solve. Negative 2 by 3, negative 2 into 3 multiplied with, this is 3 to the power negative 1 multiplied with negative 4 because 3 to the power 1 upon 3 can be written as 3 to the power negative 1 multiplied with 3 to the power negative 1 multiplied with 6 can be written as 2 to the power negative 1 multiplied with 3 to the power negative 1, which is basically 1 upon 2 into 1 upon 3. I have taken, let me try and take these also in the numerator. So this is negative 2 to the power upon 3 to the power, not written it clearly, negative 2 upon 3. Negative 2 into 3 is negative 6 multiplied with 3, negative 1 into negative 4, that's positive 4 into 3 to the power negative 1 into 2 to the power negative 1 into 3 to the power negative 1. Now I know these have the same base, so I can be added. This is alone. I notice that so since this is the negative power, so let me convert into positive power. So this will become negative 3 by 2 raised to the power 6 into 3 to the power 4 minus 1 minus 1. That's what I've done. I've combined these and 2 to the power negative 1. Now negative number raised to the power even number is always positive. What I'm saying is 2 to the power 4 is equal to, no, 2 to the power negative 2 to the power 4 will be equal to 2 to the power 4, which is equal to 16. That's exactly what I'm saying. So our negative number raised to the power of even power is always positive. So this is 3 to the power 6 multiplied with 2 to the power negative 6. I have taken this in the numerator multiplied with 3 to the power 4 minus 1, that's 2 multiplied with 2 to the power minus 1. So that's 3 to the power 6 plus 2, combining these two, and combining these two I get multiplied with 2 to the power minus 6 minus 1, that's 3 to the power 8 multiplied with 2 to the power minus 7, which can also be written as 3 to the power 8 upon 2 to the power 7. Perfect, that's my final answer. Let's move on. Let's move on to question number 2. Question 2 is 3 into 9 to the power. So I noted that this can be written as 3 in the base of 3. I also noticed that there is 3 to the power n or 3 to the power 2n here, 3 to the power n here. Let's try and convert this into some basic common base. So this is 3 to the power 2 multiplied with n plus 1 because 9 is 3 to the power 2 minus 9 multiplied with 3 to the power 2n upon, this is 3 into 3 to the power 2n multiplied with 3 cube minus 3 to the power 2 times n plus 1. Yes, so this is 3 into 3 to the power 2n multiplied with 3 to the power 2 minus 9 into 3 to the power 2n. I notice that I am getting 3 to the power 2n common in the numerator. Let's see if I can get it common in the denominator as well. So this is 3 to the power 2n multiplied with 3 to the power 3 and 3, that's 3 to the power 4 minus 3 to the power 2n multiplied with 3 to the power 1. I notice that 3 to the power 2n is common, so let's take it out common. So I'm left with 3 into 3 square, that's 3 cube, that's 27 minus 9. In the denominator also 3 to the power 2n is common. What I'm left with 3 to the power 4, that's 81 minus, this is 3 square, 2 into 1, 3 to the power 2 into n, and 3 to the power 2 into 2, 1, that's 2, that's minus 9. So this and this gets cancelled and I'm left with 27 minus 9, that's 18 upon 81 minus 9, that's 72, which is equal to 1 upon 4. Perfect. I hope you notice I made this mistake. This should have been 3 to the power 2, which I did later. Now let's move on. The next one is that we solve is question number 4. So let's try. Question 4 says has a and b both in numerator and denominator. So let's take everything in the numerator. So I have a to the power negative 1 minus 2. Perfect. Multiplied with b to the power 2 minus of negative 4, that's plus 4, everything raised to the power 7, divided by a to the power 3 minus of negative 2, that's plus 2, multiplied with b to the power negative 5 minus 3, everything raised to the power negative 5. This is equal to a to the power x multiplied with b to the power y. That's a to the power negative 3 multiplied with b to the power 6 raised to the power 7 divided by a to the power 5 multiplied with b to the power negative 8, everything raised to the power negative 5, a to the power x, b to the power y. Let's open this. That's a to the power negative 3 into 7 multiplied with b to the power 6 into 7 divided by a to the power 5 into negative 5 multiplied with b to the power negative 8 into negative 5 is equal to a to the power x, b to the power y. That's a to the power negative 21 multiplied with b to the power 6 into 7, that's 42, divided by a to the power negative 25 multiplied with negative 8 into negative 5, that's 40, is equal to a to the power x multiplied with b to the power y. So this is a and a common with a division sign, which means I will subtract the powers. So a to the power negative 1 minus of negative 25 multiplied with b to the power 42 minus 40 is equal to a to the power x multiplied with b to the power y. This is a to the power negative 1 plus 25 multiplied with b to the power 2 is equal to a to the power x multiplied with b to the power y. This is a to the power 4 multiplied with b square is equal to a to the power x multiplied with b to the power y, which means x, if we compare the base and the power, a is equal to x and b is equal to 2, not b. Y is equal to 2. The base is common, so the power will be same. Base is common, so the power will be same. Therefore, in the question, there's a tail question. They want us to find x plus y, which is 4 plus 2 is equal to 6. Therefore, x plus y is equal to 6. That's my answer. Let's move on. The next question that we do is question number 7. Let's solve question number 7. Question 7 is something is given and we need to prove that something is equal to 1. So let's start. I notice that I can write everything with the base 3. So this is 3 to the power 2n, because 9 is 3 square to the power n, multiplied with 3 to the power 2 multiplied with 3 to the power n, minus 27 can be written as 3 cube to the power n. This is divided by 3 to the power 3m, m, so I am separating them, multiplied with 2 cube. is equal to 3 to the power negative 3. I notice that in the I have 2 here and there is no 2 in the base. Let's see what I can do. So let's try and add whatever I have or subtract. So that's 3 to the power 2n plus n, that's 3 to the power 3n multiplied with 3 square minus 3 to the power 3n. I've got 3 to the power 3n common in the numerator at least. And in the denominator I have 3 to the power 3n into 2 cube, which can be taken as 8, is equal to 3 to the power negative 3. Let's take 3 to the power 3n common in the numerator. So if I take 3 to the power 3n common, what I'm left with 3 square, that's 9 minus 1, what remains here is 1, and I have 3 to the power 3n multiplied with 8, which is equal to 3 to the power negative 3. Now my left hand side becomes 3 to the power 3n multiplied with 9 minus 1, that's 8, upon 3 to the power 3n multiplied with 8. 8 and 8 gets cancelled, and on the right hand side I have 3 to the power negative 3. Since the base is the same, I can subtract the power because there is a division sign. So 3 to the power 3n minus 3n is equal to 3 to the power negative 3. Now since base is equal, which means 3n minus 3m is equal to negative 3. Let's divide everything by 3. So divide both sides by 3. If I divide both sides by 3, I get n minus m is equal to negative 1. Is that what they want me to prove? No, it is m minus n. So let's reverse the signs, take everything on the other side. So 1 comes here, n goes there, m goes there, so m minus 1, which means m minus n is equal to 1, hence proof. That's what they wanted me to prove. Perfect. Let's move on. Here, till now the questions that we've done, 3 to the power with the variable we used to get cancelled. Here, a number got cancelled. Let's move on. So the next question that we solve is question number 9. So let's solve question number 9. Question 9 says 3 to the power 4x is equal to 81 to the power negative 1. So let's see. This can be written as 3 to the power 3 to the power 4. So my first equation gives me 3 to the power 4x is equal to 3 to the power 4 raised to the power negative 1, which means 3 to the power 4x is equal to 3 to the power negative 4. Now since bases are equal, which means 4x is equal to negative 4, which means x is equal to negative 1. So I've got my value of x as negative 1. Let's see if second equation can give me something. 10 to the power 1 over by y is equal to 0.0001. I need to write this with a base of 10 so that I can equate the bases and I can equate the powers. So this is 10 to the power 1 by y can be written as 1 upon 1 with 1, 2, 3, 4 zeros. 2, 3, 4 zeros. Now which means 10 to the power 1 by y can be written as 10 to the power negative 4, because this is basically 10 to the power negative 4, which means 1 by y is equal to negative 4, which means y is equal to negative 1 upon 4. So I've got x is equal to negative 1 and y is equal to negative 1 upon 4. Let's see what they want me to calculate. They want me to calculate 2 to the power negative x multiplied with 16 to the power y. Let's replace values. 2 to the power negative of negative 1 multiplied with 16 upon negative 1 upon 4. This is 2 to the power negative 1 into negative 1, that's 1 multiplied with 16 can be written as 2 to the power 4 multiplied with negative 1 upon 4. 4 and 4 gets cancelled, so that's 2 to the power 1 multiplied with 2 to the power negative 1, which is basically 2 upon 2, which is equal to 1. Perfect, I've got this one as well. Let's move on to question number 12. Question 12 is m is given, n is given. We need to find the value of this. So let's add them. Let's take the LCM. So m square plus mn plus n square. That's the LCM. It will be m minus n times m square plus mn plus n square minus 1. Now if you remember your expansions, a minus b into a square plus ab plus b square is basically a cube minus b cube. So this is m cube minus n cube minus 1 upon m square plus mn plus n square. Now let's replace the values. So m is third root of 15 cube minus n is third root of 14 cube minus 1 upon m is third root of 15 square plus third root of 15 into third root of 14 plus third root of 14 square. I don't think I'll need the denominator, but I've still replaced values. So this is 15 to the power 1 by 3. This is third root is 1 by 3 multiplied by 3 minus this is 14 to the power 1 by 3 into 3 minus 1, and this is still m square plus mn plus n square. 3 and 3 gets cancelled, 3 and 3 gets cancelled, so that's 15 to the power 1, which is 15 minus 14 minus 1 upon m square plus mn plus n square is equal to 0 upon m square plus mn plus n square, which is equal to 0. Perfect. Now let's move on to the next question. So the next question that we solve is question number 15. So let's go to question number, no, not 15, question number 13, sorry. Let's go to question number 13. Question number 13 is 2 to the power n. I notice that this is can be written as factor of 2 and 3. This also can be written as 2 and 5. So let's convert everything. So that's 2 to the power n into 2 to the power m plus 1 multiplied with 3 to the power m plus 1. Why is this? Because this is 6 to the power m plus 1. I have written it as 2 into 3 raised to the power m plus 1, which is 2 to the power m plus 1 and 3 to the power m plus 1. Perfect. So this is basically what I've done. Now let's move on. So let's do then. Similarly, 10 can be written as 2 into 5. So that's 2 to the power m minus n multiplied with 5 to the power m minus n. And 15 can be written as 3 into 5. So 3 to the power m plus n minus 2 multiplied with 5 to the power m plus n minus 2 divided by 2 to the power 2m, because this is 4 2 square multiplied with 3 to the power 2m plus n multiplied with this can be written as 5 to the power 2 m minus 1. Let's try and add all powers of m and n, m and of 2, 3 and 5. So this is 2 to the power n plus m plus 1. I've taken this, let's take this, plus m minus n. That's it. In the numerator there's only this 2. In the, let's see, 3 power m plus 1, so 3 is gone. Let's say take this one, plus m plus n minus 2 multiplied with, now brings me to 5. So that's 5 to the power m minus n plus m plus n minus 2. Perfect. Divided by 2 to the power 2m into 3 to the power 2m plus n multiplied with 5 to the power 2m minus 2. So let's see what we get. So this is minus n and n gets cancelled. So this is 2 to the power 2m plus 1 minus 2m, because there is a 2m in the denominator, multiplied with 3 to the power that's 2m plus n. 1 minus 2 is negative 1 minus 1 minus 2m minus n. Why is this minus 2m minus n? Because the power in the denominator is 2m plus n, so it will get subtracted. Multiplied with 5. So n and n gets cancelled, so that's 2m minus 2. 2m minus 2 minus 2m plus 2. Why this negative 2m plus 2? Because this is 2m minus 2. When I subtract it, it becomes negative 2m plus 2. So this is it. 2m and 2m gets cancelled. So I have 2 to the power 1 multiplied with 3. 2m and 2m gets cancelled. N and n gets cancelled. 3 to the power negative 1 multiplied with 2m and 2m gets cancelled. Negative 2 and 2 gets cancelled. Multiplied with 5 to the power 0. Which means 2 into 1 by 3 into 1, which is 2 by 3. That's my final answer. Perfect. Slightly longish question. Let's move on to the next question. The next question that we solve is question number 15, part 1. So question 15, part 1 is a to the power minus 1. Let's try and convert this into, so 1 upon 1, a to the power minus 1 is 1 upon a. This is 1 upon a plus 1 upon b, and this is 1 upon a upon 1 upon a minus 1 upon b. That's what's given. We need to prove. So I am starting with the left hand side. This is what we need to prove. So this can be written as 1 upon a. The LCM is ab. So this is a plus b upon ab plus 1 upon a. Again the LCM is ab and this is b minus a. So this becomes 1 upon a multiplied with ab upon a plus b. This is division of fractions, plus 1 upon a multiplied with ab upon b minus a. A and a gets cancelled, a and a gets cancelled, so I am left with b upon b plus a plus b upon b minus a. Let's take the LCM. The LCM will be b square b plus a multiplied with b minus a. So this will be b times b minus a plus b times b plus a. So this is b square minus ab plus b square plus ab upon b square minus a square. This and this gets cancelled, so this is 2b square upon b square minus a square. This is equal to right hand side. Perfect, hence proved. That brings me to the last question of this exercise, which is question number 16. I notice that I will again have to take some common base. So 4 can be written as 2 to the power 2. 2 and 6 is 6 cubed. So 6 to the power 3 multiplied with negative 2 upon 3. This gets cancelled. Plus 1 upon 256. 256 is 2 to the power 6. 16 to 16, that 2 to the power 4. 2 to the power 8 multiplied with negative 3 upon 4. Plus 2 upon 243 is 3 to the power 5 multiplied with negative 1 upon 5. 4 1 4 2. So this is 2 square upon 6 to the power negative 2 plus 1 upon 2 to the power 2 into negative 3, that's negative 6, plus 2 upon 3 1 into negative 1. That's 2 to the power 2 multiplied with 6 to the power 2. I take it in the numerator, plus 2 to the power 6 plus 2 into 3. That's 4 into 36. That's 144 plus 2 to the power 6. That's 64 plus 6. That's equal to 214. Perfect. Now that brings me to the homework questions. Homework questions are question 1 part 2, question 3, question 5, question 6, question 8, question 10, question 11, question 14 and question 15 part 2. Thank you.